So I'll show you what we're doing here, okay? Oh, right here. So remember, I just took one equation with two variables. Then there are infinite amount of solutions to that one equation. So you know the xy plane. Do you ever see the xy plane where this is x, that is y, and for a specific coordinate, yeah, like you have a point somewhere, right? So that you can indicate this as, let's say, 4 and 3. That is the point in the xy plane. And for these equations where, let's say, we have x equals, well, x minus 2y equals -5, take any one of them, you'll find that because you have um, pairs of solutions, right? You have an infinite amount of pairs of solutions. And if you can see these pairs of solutions as coordinates, okay? So if I plug in 0 here, this becomes y is 5/2. Not a nice number, but still. So if you plug 0 here, you'll get x equals to -5. Anyway, you get lots of points, right? So if I indicate x as 0, y as 5/2, let's say this is 1, this is 2, this is 3. 5/2 would be here. All right? So this would be the coordinate of that point. And with this is -5 and 0. Well, x is -5. Let's say this is just half of it. Roughly here. Okay. That's about -5, right? That's another point. If you try many points, you would notice that all of the points are on this line. Okay? That's all of his solution. And as a matter of fact, the solutions for all of these equations are on a line. Okay? That's why these are called linear equations. Okay? The solutions are all on a line. Well, linear, right? Linear. Line. Right? So the solutions are all on the lines. And if you only have one line, let's say you go to a city and you tell somebody, oh, I want to meet you, right? So, and the guy says, well, where are we going to meet? And you say, well, how about First Street? Well, if that's a straight street, then you can see that as a line, right? So it doesn't make sense. You say, well, how can we meet on First Street where I don't know where you're going to be? That's a long street, right? So you may say, oh, how about one street in Fifth Avenue, right? Well, that makes sense because then I can meet you right at that spot, right? So if one of these is one street, the other is another street, you need two streets to locate a specific point, right? So that's where you meet. Let's say you have another line. So that's one equation, that's another equation. And that's our solution. What are we doing? We're finding the location where they meet. Okay? You can't just provide one line and say, well, we're going to meet there. No. Lines are considered to be infinitely long, right? You can't meet. I don't know where you're going to be. Okay? You put two lines there. So whenever you see two equations, you can kind of thinking two streets, right? So we're looking for a solution. We're looking for where they meet. Well, now from the symbolic world, we're in the the world that we can visualize, right? This is a visual world. It's actually more intuitive on this side, right? When you only look at the equations here, you're not quite sure. You just follow the steps. You know these steps will lead to some solution, right? It's like, oh, it makes more sense on this side. You know what these things are. So because we understand this now, when I ask you, if I give you two linear equations, how many solutions can I get? Consider all possibilities. If I give you two equations, think of it as I give you two roads, right? So, how many solutions is possible? Right? Well, two roads can meet at one point. Well, now you're thinking, well, don't they always meet at one point? Is there any other possibilities? Is it possible that the two roads meet at 2 points if both roads are straight, right? But if one is curvy, that's a different story. We're talking about straight streets, right? Oh, okay. So now when I ask you, well, if I say that there's always one solution to two equations, is that correct? Can you think of a situation where two streets are provided, but you still don't have a intersection?
Yeah.
How?
They're parallel.
Yes. So if I give you the first street and the third street, you still don't know where to meet, right? They're parallel to each other. So that's a situation where you don't have a solution. And sometimes it can happen. That's when two lines are parallel to each other, right? So it's possible that there's one solution. Most of the time, you would think that there's one solution, but it is possible that there's no solution, right? And it is also possible there are infinite amount of solutions. That's where a street has two different names, right? So if one guy says, we're going to meet at street A and it's street 84, let's say that's how it was presented, right? It turns out these two streets are the same street, right? So that's like, well, these two streets intersect at an infinite amount of points, so that there are infinite amount of solutions, right? That is also possible when two equations are provided. Okay, so three possibilities. Most likely, you're going to see two equations with one solution. Okay, so and then sometimes they're parallel. I would really doubt if you solve system equations in school, somebody would give you two equations that will make two parallel lines. That's not very likely, but I still want you to know that, right? And they would not very likely give you two equations that are actually the same equation. So what do I mean by two equations that are the same equation? So 2x equals y minus 1 and 2y equals 4x plus 2. Okay? These are same equations. Can you see that? These two equations are the same.